Okay guys, I just want to show you some quick Seaperch design tips. The regular Seaperch here is, this is actually a modified, but it's a pretty similar design. The great thing about the stock design is it's really balanced. And when you're making your own custom design, which I like to have my students do, you want to be balanced. So this is like a regular Seaperch, it's just a little smaller. But the great thing is when you're putting a Seaperch in the water, you gotta think it's not gonna affect gravity. So like center of gravity on this, if I was to hold it right here, maybe it's like right here. But in the water, it's gonna change because this metal is gonna weigh down heavier than this PVC. This metal on the motor is gonna weigh down heavier. So they've designed this one such that it has a similar center of balance that it would in the air, but you got to position your flotations. It looks like it might be a little heavier up here in the front where these two motors are, and that's why they've got these extra buoyancies. And you just think these are basically like little strings that pull up. Or think of like a rubber band. You have like one rubber band right here going up, pulling up on it, and maybe three right here where there's more foam. And you kind of get this balance act, all right? And another thing to think about is the drag. So drag through the hydrodynamics is how things flow through water. And you want to minimize the front surface area. So that's like if you're facing it just like this, the front view, you want this front view to be as small as possible, okay? So the more area that water has to pass through, the more energy the motors have to use to go through. So the smaller you can make that surface area, the faster you're going to go. Then also same here. You can think about when you're going up and down. You want to know how fast you're going to go up and down. Let's think of the surface area of what this looks like. You have to push a lot more up and down here to go up and down. So you'll never go as fast forward with this design as you will up and down. You will opposite, sorry. You'll go faster going forward and back because there's less surface area, two motors pushing. And this way, where there's more surface area to push the water through, and less motor spinning. This is a really good design. You can see that they added like metal screws to get some balancing on, and here, because all right. So let me show you a good design. This design right here has a very small surface area. So you can see that all it has to push through is like this little rod right here, and then these two side parts where the motors come out. Other than that, it didn't have much to push out the way. So, but they still had to balance. You'll see that they put like some weight here to balance it out, balance the hook for moving. Another thing that they have are fins. And so you can see the fins here at the front. They're stabilizers, what you'd call if they were a plane. But what this does is help. So when it's flowing through the water, if it's going up and down like this, kind of like sometimes you'll see an unbalanced Seaperch. The common thing is it's going to be like, it'll be like this. Because the motors are generally pushing in the wrong spot, and then the buoyancy is fixing it, and it's just not very efficient. So if you have these fins, what it does is it makes it's more work for the Seaperch to go up or down because it has to push through more water. So it wants to go through here where it's really skinny. So it kind of helps stabilize it, and it'll reduce that vibration that you have. And you'll notice when you get smaller and smaller designs, the more unbalanced you get. Now, one thing that's probably not very good about this design is that this bar right here is impeding this propeller that makes it go up and down in the water. And so you probably don't have much upward force. And this can be an issue because like sometimes when the Seaperch try to pick up a ring or a cube, if they don't have enough force, they actually can't pick it up. They might have get around just fine through the obstacle course, but when it comes to actually picking up, they don't have enough uplift to get that up. And so I've seen that be a problem. Another thing is where your cord gets tied to, because what's going to happen is the further you go out, the more the cord's going to weigh it down. And like some of my students put little foam things to help kind of counteract that, to kind of neutralize the buoyancy of the cord. Now the downside is this can get caught in those rings, so you want to be careful. You might, if I was me, I'd probably take this down a little bit more. And so, but this is a great design. Here's the design. It's It's really stable. You can see they left this here, so there's plenty of room for the water to flow through, and nothing's really impeding it. They used, instead of using foam, they actually used the canisters that the motors go in and sealed them up, so there's just air. So it's air that's lifting it up. And air is a lot more efficient. You don't need as much volume, space, as you do with foam, so it has less drag, but it also is has a lot more pull. So you can see they've really had to weigh theirs down to account for that. So if you can find like a small like test tube or something, you know, it's like plastic, that'd probably be a really good way. Long too. That'd be, you know, small, long, would be really good there. And they got these hooks that they put on the front of them. And you'll see I have them wire lights on them. And so on the controllers, there's a lot of extra stuff. I recommend if you want to do a cool modification, buy the like Cat 6 cable or the cables that have more wires that go to it, because what you can do is you can use those extra wires, and even the stock Seaperch comes with extra wires, to make new circuits. So like this one has a light that you can turn on and off right here with this button that they've added in. Okay? And so that's a really cool way to modify it. You could have like a servo tester and a servo if you have 3 extra wires, where you can move the servo. You can't really share grounds. This is the downside with the way these motors are wired. Another design consideration that really gets a lot of students is attaching these motors. The system that the Seaperch motors use is just not very good. It, you know, it's glued on there, and if it doesn't have a good glue seal, it just doesn't stay on and they fall off. And if this starts to fall off, those Seaperch never win. So I don't know if we need to find a new glue or what. Sometimes I have them like hammer it, put like one hit with a hammer on something flat to kind of press that metal together. But it is just, it's really sad when that happens, because I've seen some of my best design, or not my best, my students' best designs not go through. I have these 3D printed parts here, if you can see here, these different motor mounts. I have a bunch of them. I'll link them. If you want to print some out, you can. Like this one goes around the actual pipe fittings, the connectors. And this one goes around the tube right here, and then they all fit the motors. And there's a bunch of different variations where you can make. Same with these stabilizers. You know, I have different stabilizers and fins that you can use to kind of help stabilize. I have these different angles, so if you want like a really sharp angle, you know, you can get that. Like you can see here, they've got this wider angle right here. You can combine that with like a sharp angle to go back. And this is a 3D printed part that they have. And then like, this is like a 4-way connector, or not 4-way, 6-way connector. A lot of options that you can do. You know, when you're playing around, I recommend just kind of playing like Legos. You know, you can. I have a box of a bunch of like stock. Sorry, this all fell. Stock PVC parts, and you know, you can just start putting them together and see what you think is going to be balanced and stable. But you know, you really have to think about balance. So look here. Let's say you've got your 2 motors in the back, and they're way down low like this. Okay, what's going to happen is when these motors push, they're going to push up like this, and then this buoyancy is going to kind of try to correct. And it's going to go like this, or it's going to find this equilibrium of going like this, and it won't flow straight through the water. So what you want to do is kind of try to reduce that. You want it to, the place where you're pushing from, to be not so far off from your force or your drag. And if you have that, it pushes a lot more smoothly through the water. With your up and down, you need this almost positioned at the same place where your buoyancy is, because this is going to give you an equal push down. I've definitely seen some that when they're pushed out like this and they start to go down, it pushes it down and it doesn't go straight up and down, it goes at an angle, and it's really hard for those students to get it. But I will say sometimes a little bit of a down and up is good for picking up the objects. So, yeah, you know, you want this positioned similarly in the balance, and that's why a lot of times you see the two sides, because if you have this right here, the water can't pass through right here very well. And so if you have it split into two spots where the buoyancy is on this side and this side, can flow through, you've got a stable balance. And so, like I said, really recommend just trying to make it as small and balanced as possible. It's a tough thing to do. You can add the stabilizers. This, believe it or not, this circle from this tube, this cylinder, isn't very hydrodynamic. So you could try to put like, an angled or like a wing type shape around it to help it smoothly pass through the water and create less drag. Those are going to be the real things that help you. So I recommend doing a lot of testing. Go in the water, test, see what works, see how it kind of flows through, and then make your changes before the actual competition if you can. But really try to minimize in the weight. So I know it's more mass than weight, but the mass of it still have those props still have to push that mass through the water too. So it's drag plus the mass, and then the power of their motor is what you're going to get on your speed. So if you can reduce your drag, you can reduce your mass, you're going to get more speed. And the trick is find that balancing act of where to balance, how much you have to have. Another thing that you can do to modify, as you'll see in this one, they've got different props in the back. They went with these props right here. Now these props are 3 blades, and they're not as large of a diameter, so they're not as wide as the stock ones. They're smaller, and they have more of a pitch, which means more of an angle. So this is like a lot of pitch. This is not much pitch. Okay, and this kind of propeller is really good for going forward. It's not as good for going backwards. So it probably won't go backwards very fast, but a lot of times in Seaperch competition, you don't need to go backwards fast. So it's better to have a motor that's more efficient at going forward for the back 2 motors. But for the one that goes up and down in the middle, you see they use the stock propeller, and it's good at going both up and down. So it's really good for in the middle. And let's see if there's anything else that I can say here. I like the lights. I love these metal hooks. I think they work really well. I love these extra 3D printed joints. The foam works well. I like the air. If you can find, you can even seal. I've seen people seal up the PVC tubes. They get the cap ends and they use the PVC glue and they cap it, and so their buoyancy just looks like it's actually extra PVC, a tube of PVC that goes over the top, and that's a good way to do it too. But yeah, play around. It's a lot of fun. I really like having my students do this. You can make different designs. This is one we were doing for, we're going to do an ROV to go and check out life at the bottom of like some lakes in Oklahoma. And, you can add multiple thrusters. You definitely have to start getting into like batteries. We were thinking about switching these from brushless, but this was one of their designs that they were working on. And you can kind of see this looks like a lot more similar. It's box, you got the thrusters, you got a lot of balance, and that's what you're going for. So, all right, I hope that helped you guys.